Morning everyone. Today we will explain asymptotes. First, we have the horizontal asymptote, symbol is HA. If limit as x tends to plus or minus infinity of f of x equal to b, where b is a number, then y equal to b is a horizontal asymptote for the curve of f, for c of f. Graphically, if we will take our first example by calculation, if we have f of x equal 2x minus 3 over x minus 1, we will make limit as x tends to plus infinity of f of x. This is a rational function of two polynomials. We take the leading term in the numerator and leading term in the denominator. Second step, we simplify if possible. We can simplify 2 by 2, x by x, then the answer is 2. We make limit at infinity, the answer is a number, then y equal to 2 is horizontal asymptote at infinity. If we want to see this one graphically, y equal to 2, this is a line parallel to x-axis. This is x-axis, and here we have y-axis. First we will draw y equal to 2. This is the line y equal to 2. Limit at infinity is equal to 2. What do we mean limit at infinity? Here we have x going to plus infinity. Then as we go to plus infinity, the graph should be always reaching 2. Can't cut the line y equal to 2. Suppose this graph is decreasing function like that. It will stay reaching 2 but without cutting it. Here we have limit as x tends to plus infinity, the answer is 2. And if it is an increasing function, it will reach 2 from below. For example, in this case, it will stay very close to line y equal to 2. Second one, we have vertical asymptote. The vertical asymptote, the rule is if limit as x tends to number, not infinity, of f of x is equal to infinity plus or minus infinity, then here we have x, then x equal to this number is a vertical asymptote. In most of the cases, this number we can get it from the domain of the definition. For example, if we have limit as x tends to 1, here we will want to make 1 minus and 1 plus. 1 minus of f of x equal minus infinity. Limit as x tends to 1 plus of f of x is equal to plus infinity. We make limit at a number, it gives infinity, then x equal to this number is a vertical asymptote. For example, if we have f of x equal 3x over x minus 1. If we want to make 3x limit as x tends to 1 minus, why we say 1 minus and 1 plus? Here the domain of definition, x not equal to 1, so it is minus infinity 1 union 1 plus infinity. Usually we make limits at the open boundaries of the domain, which are minus infinity and plus infinity, and we have 1 minus and 1 plus. Limit of f of x as x tends to 1 minus, it's equal 3 times 1 over 1 minus minus 1. 1 minus, we mean a number is less than 1, which gives 0 minus, so the answer is minus infinity. And if we make limit as x tends to 1 plus of f of x, the answer will be 3 over 0 plus, which is plus infinity. Why? Because if we have 3 over 1 plus minus 1, what do we mean by 1 plus? It is a number greater than 1. It will give 0 plus, so the answer will be plus infinity. Now, graphically, a vertical asymptote. In this example, here we have x-axis and y-axis. X equal to 1 is a vertical asymptote. Here we have x equal to 1. The limit as x tends to 1 minus is minus infinity. First one. Here we have 1 minus, and here we have 1 plus. 1 minus, we mean it is before 1. Before 1, it is minus infinity, it's below. So maybe it's decreasing. Of course, it will be decreasing to reach minus infinity without cutting this axis in this case. And limit as x tends to 1 plus, here we have 1 plus, the answer is plus infinity. As we mean coordinates of a point, it is 1 plus infinity. Here we have 1 plus, we go to plus infinity, start from here, and it will be, for example, decreasing in this way. Here we have, as we getting closer to 1, the answer is plus infinity. Now we have oblique asymptote. Oblique asymptote, it's not horizontal and not vertical. So the equation of this oblique asymptote will be y equal ax plus b or y equal ax. These are two kinds of oblique asymptote. The rule of the oblique asymptote we make if limit as x tends to plus infinity of the function minus the line y of this line is equal to 0, then y equal ax plus b is an oblique asymptote. For an example, if we have f of x equal x plus 3 plus 2 over x minus 1, and line D of equation y equal x plus 3. If f of x has this form, usually the line which is near the fraction will be the equation of the oblique asymptote. First, we make calculation of y, f of x minus y, which is, this is f of x minus y, which is x plus 3. You can see that x plus 3 and minus x plus 3 will be cancelled. The answer will be 2 over x minus 1. Now, limit as x tends to plus infinity, for example, of f of x minus y equal 2 over infinity, number over infinity, the answer will be 0, imply y equal x plus 3 is an oblique asymptote. Example 2, if we have f of x in different form, which is x squared plus 5x minus 4 over x minus 2, and the line D is of equation y equal x plus 7. First, we want to calculate f of x minus y. It is equal to x squared plus 5x minus 4 over x minus 2 minus x plus 7. We should make same denominator. Here we have 1 times x minus 2 times x minus 2 then the answer will be x squared plus 5x minus 4 minus, here we have to make expand, x squared minus 2x plus 7x minus 14 over x minus 2 equal x squared plus 5x minus 4 minus x squared plus 2x minus 7x plus 14 over x minus 2. X squared is cancelled by x squared. 5x plus 2x equals 7x. 7x minus 7x will be cancelled. Minus 4 plus 14 it's equal to 10 over x minus 2. Now we will make limit as x tends to infinity of f of x minus y equal 10 over infinity minus 2. 10 over infinity is equal to 0. Then line D of equation x plus 7 is an oblique asymptote. Now we have asymptotic direction. We have if limit as x tends to plus infinity of f of x gives plus infinity or minus infinity, it is a case of oblique asymptote. Of course it is not horizontal, then it may be oblique asymptote as we see before in the last explanation, or it may be an asymptotic direction. What do we mean by asymptotic direction? First case, we have if we calculate limit at infinity, the answer is infinity. If limit as x tends to infinity of f of x over x, if the answer is infinity, then it is an asymptotic direction parallel to y-axis. How it is parallel to y-axis we'll see after that graphically. Part B. If limit of f of x over x, limit as x tends to infinity of f of x over x, and the answer is 0, then it is an asymptotic direction parallel to x-axis. At infinity, the answer is infinity, but we want to see how it is exactly going at infinity, in parallel to y-axis or if it is parallel to x-axis. And the last case, which is we get from it the oblique asymptote, and usually the question will be here, show that without finding it. If limit as x tends to plus infinity of f of x over x is a number which is constant number, which is a constant, here it is a case of an oblique asymptote. What is the equation of an oblique asymptote? It is y equal ax plus b. Now we have how we find b? Find b, which is equal to the limit as x tends to infinity of f of x minus ax. For example, if a is equal to 3 and here the answer of this one is equal to 2, then y equal 3x minus 2. Here will be the equation of the oblique asymptote. But usually the oblique asymptote, the question will be show that y equal 3x minus 2 is an oblique asymptote. Now to see it graphically, how it is asymptotic direction parallel to y-axis. Parallel to y-axis like that. It continues at infinity, but it is parallel to y-axis. Sorry, this one parallel to x-axis. This is the x-axis. And now at infinity it is parallel to y-axis in this way. It continue like that. Or it can be more parallel to y-axis in this case. Any student can write or can draw the graph in this way or in this way or in this way, but if we calculate the asymptotic direction in part A or in part B, we can exactly know if it is parallel to y-axis or it is parallel to x-axis. Here we have some examples graphically about the horizontal asymptotes and vertical asymptote. For example, we have limit at plus infinity equal to 3 implies that y equal to 3 is an horizontal asymptote, and we have limit at minus infinity equal minus 4 implies that y equal to minus 4 is a horizontal asymptote. For example, the graph is increasing from minus 4 to plus 3. It is increasing, so we start first at x equal minus infinity. Here we have x equal minus infinity. The answer will be minus 4. So we'll start from here and start increasing, for example, by this way to reach 3 at plus infinity. It started minus infinity minus 4 to reach plus infinity 3, which is here is a horizontal asymptote, and here we have it is a horizontal asymptote. In example 2, we have the limit as x tends to 3 minus equal to plus infinity, and the limit as x tends to 3 plus is minus infinity, so x equal to 3 is a vertical asymptote, and the limit as x tends to plus or minus infinity is equal to 1 implies that y equal to 1 is a horizontal asymptote. Suppose that this function between, here we have x equal to 3, we have at 3 minus it is a plus infinity, here we have a 3 minus, and here we have a 3 plus. At 3 minus it is a plus infinity, it is somewhere here, and at minus infinity, here have x equal minus infinity, it is 1. So it is increasing from 1 to reach plus infinity in this way, for example. And at 3 plus, it is minus infinity. So it's below x-axis. Here we have 3 plus, it is minus infinity, it is increasing to reach y equal to 1, which is a horizontal asymptote. Now, according to the oblique asymptote, we have the relative position between the curve and the line, which means where in which domain we have the function above the line and where the function, the curve of f, is below the line. In order to study the relative position between C and D, the curve and the line, we should study the sign of f of x minus y. The steps are, first we calculate f of x minus y, then we find the roots of fx minus y equal to 0, and we make table of sign to see where it is positive and where it is negative. Example 1, we have f of x minus y. We start by f of x minus y. It's equal to x squared plus 4x minus 5 minus x minus 5. It's equal to x squared plus 4x minus 5 minus x plus 5. We have minus 5 and the plus 5 are cancelled. X squared plus 4 plus 3x. We put f of x minus y equal to 0. It is square, we can factorize to get the roots, or by calculator it's a quadratic, x equal to 0 or x equal minus 3. Now we make table of sign, minus infinity, minus 3, 0, plus infinity. Here we have the roots. It is a quadratic. The coefficient of x squared is positive. Same, opposite, same. So the answer will be, for x belongs to minus infinity minus 3 union 0 plus infinity, we have f of x minus y positive. It means that f of x is greater than y. This indicates that c is above d. And for x when x belongs to minus 3, 0, we have f of x minus y is negative, then f of x is c of f is below d, and for the roots where x belongs, this is a set minus 3 or 0, f of x minus y equal to 0 imply c intersects d. Here we have another example. We calculate f of x minus y. This will be the answer. We put f of x minus y equal to 0, x equal 3 over 2. We want to make table of sign of this rational function. For first polynomial, we have opposite same. For second polynomial, we have opposite same, but here we will put the bridge since we have a rational function. So the answer will be minus plus minus. In the same way, for x belong to minus infinity 1 union 3 over 2 plus infinity, we have f of x minus y negative, so c is below d. And for x belongs 1 3 over 2, we have c above d. And for x equals 3 over 2 only, it can be equal to 1, c intersects d.